Hello tech community, welcome to P-TekLearn. In this video series, we will explore Amazon SQS, covering everything from the basics to advanced concepts, along with the hands-on exercises. In the first video of this series, we will cover the fundamentals of Amazon SQS and explore its architecture. Before starting the session, please subscribe to our channel if you haven't already. Your support motivates us to create more videos helping you stay updated with advanced technology trends through straightforward, simple and enjoyable tutorials. SQS stands for Simple Queue Service. SQS is a secure, durable, scalable and reliable distributed messaging service that uses queues for exchanging the messages. SQS is mostly used to integrate and decouple distributed software systems and components. Setting up SQS service is very simple and very straightforward. With a simple configuration and setups, we can configure the SQS on AWS account. Once the SQS service is configured on AWS account, we can use any API or a microservice or any application that is developed by programming languages like Java, Python, Go, .NET and so on by calling the web services that is provided by SQS. The basic architecture of SQS contains three main components. First one is producer and consumer applications. A producer or a consumer application is an application or an API or a microservice that is developed in one of the languages that is supported by AWS SDK, like for example Java, Python, .NET, etc. Queue is the second component of this basic architecture. Queue is distributed on Amazon SQS servers. A single queue can be distributed on multiple Amazon SQS servers to provide high availability and resilience. The third component in this architecture is message. Message is nothing but the information being exchanged by producer and consumer applications. A message contains a body along with metadata attributes like message ID, timestamp that message was created, and some other attributes which we are going to explore in a moment. In this basic architecture diagram, we see a producer application that contains a message, a consumer application, and a queue. In the queue, we see multiple servers. In this diagram, there are three servers. So a queue is distributed on multiple SQS servers. Here, the producer can be an API, an application, a tool or another AWS service that is going to produce a message. The producer has a message and it wants to send that message to SQS queue. Consumer is an application which can consume or receive the message available on the SQS queue. Similar to producer, consumer can be an application, an API, a tool or another AWS service that wants to consume a message that is available on the SQS queue. The producer, in order to produce or send message M, it should have all the details of queue like queue name, queue address, etc. So when producer sends the message M, then that message will be stored in the queue on multiple servers. As you can see here, the message M is redundant. Multiple copies of message M are stored on multiple servers of this queue. So in this picture, in this example, we have three servers in the queue. And each server has one copy of message M. And the consumer application which contains the details of this queue like its name and address and other details can consume that message from the queue. So here, message M is received by consumer. The receiver application or the consumer application receives the message by polling the queue. Once the message is received by the consumer application, the consumer will do its processing. So processing message is something like inserting that metadata which is part of that message into a database, or using that data for some other application is part of that application's processing. Once the message M is processed by the consumer application, the consumer will delete all the copies of that message M on Q. The redundant copies of message M on the servers will be deleted by the consumer once that message M was processed successfully. The consumer application deletes the copies of message M on the queue to avoid the duplication of the messages. So other consumers or the same consumer could not consume this message again and again. So this simple basic architecture explains us the simple mechanism of message exchange between the applications using SQS queue. Producer application is producing the message and the consumer application is consuming the messages through a service called SQS. SQS has a queue and that queue is distributed on multiple servers. That's it. That is the simple and basic architecture of SQS. Now we have to understand the third component of this basic architecture, message. Message has a life cycle. So as we have seen that in the previous slide, the message was deleted by the consumer application once it processed the message successfully. In addition to that, the message will be deleted automatically by following the retention period, which is a property of the message that was set. Even if the consumer application hasn't deleted the message after consuming and processing, there is a property that automatically deletes the message from the queue. That is called a retention period. The retention period of a message is 4 days by default. We can customize the retention period at the time of creating the queue. So in the queue, we can mention the retention period in terms of seconds or minutes or days. The minimum value of the retention period is 60 seconds and the maximum value that we can set is 14 days. So these are the basics of Amazon Simple Queue Service. In this video, we have explored the fundamentals of SQS, the basic architecture, multiple components of the basic architecture, and we saw how the message can be exchanged between two applications by using queue. So with that knowledge, in our next video, we'll do a hands-on exercise to log into AWS console, create an Amazon SQS queue, send a message, poll a message, and read the body and metadata of that message. And finally, how to delete that SQS queue from our AWS account. Thank you for watching our video. If you like this video, please like it and then subscribe to our channel. See you in the next video. Bye now.